Hello, this is Xiaopeng Chen. I will present with the group mate Shun. Today we will focus on the time series analysis from the room temperature data from Kaggle. Here is a summary of the data frame. The data is from the Vitel on Kaggle.com, which has 3 variables and 7056 observations from January 4, 2022 to October 24, 2022. The key variable is the hourly temp, which has mean temperature 21.87 degrees Celsius, minimum 5.35 degrees Celsius, and maximum 36.5 degrees Celsius. This is the visualization of our time series model. The left one shows the whole model from 0 to the end with the frequency equal 24, which represents the average temperature data for the whole day. Meanwhile, the right plot shows the hourly temperature changes for first 5 days to show the minority change of temperature. For further analysis, we will focus on day change, try to forecast average temperature for next 10 days. In this pattern, we observe a clear diurnal cycle, with temperature generally rising during days and falling after night. This daily pattern suggests the presence of seasonality in data. Additionally, there are some notable trends and potential anomalies. For instance, we can see some spikes which may correspond to unusual weather events or measurement errors. Given the observed patterns in the data, we choose a Riemann model for our time series analysis. A Riemann is well suited for time series data that exhibit trends and seasonality. Next, it will be presented by Shun.
Okay, now I will talk about the parameter estimation. Here we use the auto-Riemann method and get the estimate here. The first 510 stand for the order of the autoregression component, the order of differencing, and the order of the moving average component. The second 200 stand for the order of the seasonal autoregressive component, the order of the seasonal differencing, and the order of the seasonal moving average component. Note that here BC stands for that we actually apply the box transformation to the dataset, and I will talk about it later. And by using this method, we get the estimation of the parameters. Then we should evaluate the module by residue analysis. So we first like to extract the residues from the built model and then plot the residues against the time. And then we perform the augmented Dirichlet-Fuller test. And then we plot the ACF and the PACF. After that, we check for the normality of the residues and also detect the outliers. So here is the residue plot. We can see that across the time, the variance of the residue is relatively constant, and the mean of the residues is approximately 0. And here is the ACF plot of the residues. We can see that there are few lags, so the bar exceeds the threshold. For the PACF, there are also at a few lags, the bar exceeds the threshold. And here is the histogram of the residues. We can see that it is approximately normal, like the mean is around 0, and it is symmetric. The distribution is symmetric. And for the outlier, we can observe that there do exist many outliers through the box plot of the residues. Okay, now let me summarize. So we conduct a time series study on a time series data with frequency equals 24. So for each hour, we get a temperature. And we try data transformation, like use what we have learned in the lecture. So use the box transformation. And the model specification, like we use the auto parameter selection method to specify the particular model. And after fitting the model, we conduct model diagnostics through residue analysis. And based on the residue analysis, we see our model is not perfect and not powerful enough to model the underlying patterns. So we may turn to more powerful techniques in later studies. Thank you.